Hello students, this is the first video of this academic year. Welcome. Today we are going to do transformations in this video. This is for pre-calculus. It's just a recap of Algebra 2. Algebra 2 where you have learned a lot of transformations, hopefully. So this is a recap, a review of what the transformations are. So I have a function here, f of x equals square root of x, right? So square root of x is a square root function. I just took this as an example. You can take any function here for that matter. You could take quadratic, you could take a cube root function, an exponential function, whatever the function may be, it is defined as f of x here. And whatever transformations I want to make on this graph, I could as well just say f of x minus 2 over here, which means that I am actually working on the x here inside. So this is same as square root of x minus 2 when you write it. So we'll do that writing part a little later, but I just want to give a visual before I go, so it'll be easier to see on the graph here. So I chose square root function because it is so easy to see all the transformations on the square root function, more than even quadratic. So when I say f of x minus 2, right? So when I switch this function on, f of x is the square root function, which is the red graph here. And when I say f of x minus 2, you see that it is going 2 units to the right. So you see that it went 2 units to the right. So that is the blue function. So what does it mean? F of x minus 2, when you say x minus 2, the graph is actually going to the right. Okay. If I say f of x plus 2, you see that x plus 2 is making the graph go left 2 units. So this is the main thing, my dears. So when you are actually working with x inside the function, which also means that it's square root of x plus 2 and x minus 2. So whatever is happening, it's happening with the x. So that is a horizontal movement of the graph. So if it's 2 units to the right, it means you have to take it as x minus 2. If it's 2 units to the left, you have to write it as x plus 2. This is kind of an opposite behavior that you would normally expect. So that's why I call this naughty child. These are naughty children. All horizontal stuff is naughty. Let us put it that way so it's easier to remember. So now I'll switch these off and I'll put f of x plus 3, which means it's actually going as intended to the top. Now whatever is happening outside of the function, it is vertical. So 3 is being added to the function outside of it. So the y value is changing. So the y value has gone up by 3 units. So f of x plus 3. So it went up 3 units, and when you say minus, it goes down 3 units, right? So this is behaving as we are intending it to behave. So I call these good children, like good child, only because it is behaving as what I expect it to do. So that is horizontal translation, and this is vertical translation. Now let's look at stretch. So you have here 3 times f of x, and the 3 is being multiplied outside of the function. Remember how I'm stressing on the word outside and on the word inside? Whatever is happening outside, it pertains to vertical. Whatever is happening inside the function, it is horizontal. So that is the bottom line. So there's so many things to remember. So when you say 1/3, okay, so first of all, let's see 3 times of f of x. What is happening? The graph is stretching vertically. This is called the vertical stretch. The graph is stretching vertically by a factor 3, right? It means the slope of the graph has increased. When I say 1/3 of f of x, the graph is as though it's being pushed down. It's like compressing vertically from here, this way. Alright? So, that's with the vertical stretch, vertical compression. So vertical stretch happens when the factor 3 is greater than 1. A compression happens when the factor is less than or between 0 and 1. I cannot say less than 0 because when it's less than 0, it's also reflection, which is the case here. But we'll quickly go to these two and then come to the reflections. So this is vertical stretch and vertical compression. How about horizontal stretch and horizontal compression? Whatever happens inside, again, this is horizontal, right? So 3 is being multiplied to x inside the function. And if I say f of 3 times x, it is actually horizontally. Now you have to look everything horizontally. Horizontally, it's getting compressed. Horizontally, it is getting compressed by a factor 1/3. You have to make a reciprocal of it, of this factor, of the number. And when I say f of 1/3 of x, so this is also red, by the way, but we can change it. But if you see this, then let's take it as a purple line, right? So this is 1/3 x. So it is stretching horizontally. It is stretched so by a factor 3. So you have to make a reciprocal of whatever is the number here. So that's with the horizontal. Now let's go to the reflections. When the negative is outside of the function, it's a vertical reflection, meaning it is reflecting over the x-axis. It's reflecting over the x-axis. And if it is f of negative x, it's reflecting over the y-axis, which is this way, right? So that's how it is. So once you get this straight, the packet will be easy, right? So let's go to the packet now. Here, so let's quickly write this. I'm going to take the tools. So here, let's say K. K is for the translation, K units up or down, right? If it is down, then f of x, if you call f of x as the parent function, in this case it is a quadratic function. So if f of x, it's going down, then you would write as minus k. Let me write it clearly. F of x minus k. If it is going up, it is f of x plus k. This is the good child. This is a good child. Okay. Now let's go to the naughty child. The naughty child is whatever is happening inside the function. So this time let's take h units left or right. Correct? So when it's going left, whatever is happening, it's inside the function x minus, sorry, plus. When it's going left, it's plus. That's why it's naughty. If it's going right, x minus h. So we call this a naughty child. Okay. Now the reflections. When it's reflection over the x-axis or the vertical reflection, because all the y values are getting negated, this is negative of f of x. The negative is happening outside. And reflection over the y-axis, the negative is happening inside, f of negative x. So we can actually even summarize here. Everything outside is vertical and happens with y value, and everything inside is horizontal and happens with x. Okay. All right. So let's quickly move on. Now here we have compression and stretch. As I say, A is the stretch factor for vertical dilations. And if it is a compression, you will have 1 over A of f of x. And if it is a stretch, it is A times f of x. And it stretches vertically by a factor of A. And when you see a horizontal dilation, everything is happening inside. So horizontal dilation, f of 1 over b x. And the stretch is again f of, no, this is where even Miss Madhvi gets confused. Pardon me. This is compression is b times x, stretch is 1 over b times x. and it stretches or compresses by a factor of 1 over b. You have to flip this number. Alright, if you actually see this and that, they are same, meaning it's opposite of what you're intending, right? If you remember it this way, it will be easier. Not necessarily true, but it's easier to remember that way. Now let's take examples. This looks difficult, but this parent function here is a step function, which is y equals step x. So they use a double line here, but you can, when you write it, you just use square brackets. So if you see here, x minus 5 and a half here. So x minus 5 should ring a bell. It's a naughty child. There is a horizontal translation. I just use short. You can actually use H and T. That's fine with me. Horizontal translation, right 5 units. And there is a half here. You can actually write it as half of x minus 5 as a step function. That's fine. That's how you can see that as. So that half is happening inside the function. So this is a horizontal dilation here. So it is a stretch horizontally. You see this? It's 1 over b. So it's a horizontal stretch by a factor 2. You have to flip it. Remember, you have to flip the stretch factor for horizontal. Now we'll see the minus 1. So this is happening again outside the function, so it's all vertical. So vertical translation down by 1 unit. Okay. So I'll put up the key also so you can see the answers. So I want you to try. Here the parent function is square root. So y equals square root of x. Here the parent function is quadratic. Y is x squared, and so it is here. Okay. You have to describe each transformation here. Now this is a cube root function. The parent function is cube root of x. Okay, you may call it as f of x or g of x, whatever. But it reflects in the y-axis, meaning it's reflecting over the y-axis, right? So which means the negative is happening inside the function. So it's cube root of negative, but it's going 4 units to the right, and that is also happening horizontally. So this is going 4 units to the right. If you write this as cube root of negative x minus 4, this is not same as this. Because do the going to the right first and then put the negative then. Otherwise, this is same as, you could write this is same as cube root of negative x plus 4 if you actually distribute it. So this is correct, but this is not. Be careful in the way you're writing it. Then horizontal compression by a factor of half. If it is a horizontal compression, make a reciprocal of it. It is twice of, and it's going 2 units down. So we are good. So it's actually twice of x, cube root of 2x minus 5. That minus 5 is outside because going up and down is outside. So that's the transform function. Okay. Now, like so, we have all this, write down the transformations. I don't know how much I can cover. It's already 1 minute away. So I'll make another video quickly for that also. Alright. I'll do the rest in the next video. Thank you for watching.